Yeah, I don't have any problem.
Yep.
All right, thank you very much, everybody, for coming today. These are our, not presentation of the day, but we're pretty excited to talk to you about a little bit of the quieter you become, the more you're able to help. I mean, if anybody's wondering what that actually means, just it's in relation of transforming data and actually trying to work with the right data in order to do any type of like hunting, instant response, and things like that. So we're going to go through a lot of different things that is going to involve the whole, I would say, data pipeline from like collecting data all the way to visualize it. And I'm going to start with me.
Yeah, this is me, father, husband, basically just an all-around dude. Just literally implement what smarter people do, like him and Corey and other people, right? So contribute to a few projects, open source projects, and I'd like to thank my wife for supporting me over the last year, traveling 15 states and a few countries. So gotta give her a shout out.
Yep. All right, my name is Roberto Rodriguez. I work for Spectorops. I'm the author of a couple of projects in GitHub. For example, 300 Playbook, the Hunting HELK, and also the Invoke Attack API, which moves data from minor attack framework, the whole database, and start giving you in a more meaningful way. And I'm a former senior threat hunter for Capital One, where actually I started doing a lot of development of their hunting engagements and things like that. So what we're bringing today is a combination of Nate's experience and also my experience on developing things for hunting and things like that. Today we're going to be talking about, first, just a little bit about the state of where I've seen, for example, organizations are from a collection, transformation, storing, and also visualization perspective of data. After that, we're going to talk about a little bit of the collection, what are the needs, things that you need to collect, and how you need to collect the transformation of the data as well. And then at the end, we're going to show you a little bit of the benefits of actually doing it right and how it affects all the way. Like, it's not just a matter of pushing your data all the way to a database and they just expect to be awesome and do a lot of cool stuff. So we're going to show you a couple of the benefits of all that. So once again, this problem is I like to just separate it in 3 categories. And that's because I think it's easier just to focus on little pieces at a time. And the first one, I've seen a lot of organizations now doing it at least right from a collection perspective. And now they have the right, I would say probably attitude and the right also expertise where now they're enabling, for example, PowerShell logging and things like that. They're moving now into like using some type of like OS query or Sysmon and pulling all that data. Something that I think that there is still a little bit of confusion is actually the specific techniques that you can do to collect that data. And there is actually a paper by Jared Atkinson, actually. You can have the link in there. But basically talks about 3 different ways to pull data or the data available in your environment as well. So the first way is point in time. So it's something that you will need some type of like scripting capability, and I want to show you how that actually happens. Historical time is just your Windows event logs. It's something that you have right out of the box. And real time is something that you need to add, like an agent, monitoring for new things such as Sysmon or EDR and things like that. And of course, the challenges right now that I'm seeing a lot are actually what else do I need to collect, and how do I actually prioritize what to collect in my environment. And of course, the other challenges are like, it would be awesome if you have only Sysmon, let's say, or OS query pulling data. You have a lot of stuff actually running in your environment, and I'm actually amazed every time I go to to a client, the different type of tools that they have. That some of them do the same thing, and of course you have your EDR solutions on the top of it to the rescue, right? So when you kind of like collect all that data, you're actually creating a lot of noise, and that's what the talk was like. The quieter you become, the more you can hear actually. If we move to the transformation piece, I guess that there is also a little bit of confusion between where you need to transform, filter, massage your data, and depending on what technology you have, for example, you might do it in real time, so you might have a pipeline before it hits your database, or you wait until your data gets to your database and then do transformation at query time. Very important to remember that because that would also define how you set up your environment, things like that. And of course, the challenges in there, a lot is, there are different data sources with different formats, different data fields that give you the right, same value, and vice versa. So it gets a little weird, and of course that's gonna affect a lot of your, procedures such as your, hunting engagements, your incident response operations, and things like that, because you will have to go to different dashboards with different data sources. So it affects all the stuff, and I'm seeing that a lot. And of course, from a storage and visualization perspective, I think that one of the biggest challenges is, big data. Now everybody's throwing everything to their databases. Now you have to know what you need to collect and things like that. So there's a lot of companies that are moving from great technologies just because of the amount of data that they have. And of course, if you're going to start doing visualizations, the more disparate your data is, you're going to be showing a lot of stuff and having, for example, your analysts going to different tools just to pull different, data sets and things like that. So if this is happening in your environment, believe me, it happens, in Fortune 10 companies, Fortune 50 companies, they're actually doing it just like that. So just to let you know, that's pretty much what's happening. So today we're going to be talking a little bit of what I've talked to some people, and they say, man, it's boring to do transformation of data and talk about like documentation of all this metadata, every single field that I have in my environment. I like to do the cool stuff. I like to just grab the dashboard, do some queries, some joins with this great technology, and just find evil. Well, in order to be here, you have to be talking about the cool and a little bit of the cool stuff and the so boring stuff. So we're going to start with what to collect. And this, I'm just going to go real quick because I already explained a little bit of the challenges. But I think that one important thing that I have actually to share with you with a couple companies that I've been to is that the question is, what do I need to prioritize, right? I have all this stuff right here in my environment, and a lot of them are already moving to following some type of like attack, right, framework, or MITRE ATT&CK framework. Everybody familiar with the MITRE ATT&CK framework here? Right? It's funny. It's like, all over the place, and everybody's using it for different type of scenarios, red team, blue team, incident response, anything, right? So the big thing about using the MITRE ATT&CK is that you can actually start, for example, taking a look into every single technique that different teams are actually associating to. For example, in a red team report, they say you might need to actually have accessibility features turned on or some type of logging actually to gather that data. Blue team could say, you know what, after our research, we believe that we cannot even catch that stuff. So you have different teams talking about the same type of framework, and one good thing to do is to look into the data sources part of every technique of MITRE. And as you can see here, we have, we need like file monitoring, process monitoring, or Windows registry keys and stuff like that. But when you go to for example, access token manipulation, you're still actually now getting API monitoring, for example, access tokens, and this is where the conversation about host-based detection techniques comes into place, because now you know what you need per data source. For example, for API monitoring, I think that's actually native on the box, and actually people are using scripts to get that data. If you want something like process monitoring or registry, you might need probably Sysmon and things like that. So that's really important to start understanding how to collect all the data. And at the end, for example, something that I did for an organization too was to start telling them exactly where they are from a coverage perspective, and focusing on specific tactics of the whole MITRE ATT&CK framework. And here you can see that when we talk about an EDR solution, just keep that in mind. From a coverage perspective, it looks great, right? They tell you that they can pretty much touch every single tactic, and they can actually give you most of the data that you need per technique, which at the end transform into like per tactic, I'm helping you 89% for persistence, for example. But the reason why I say keep that in mind is that this is just from a data coverage perspective. If you go to the link at the bottom, that one pretty much is going to show you how you can explain a little bit of beyond just the coverage, where you start talking about data quality and things like that. And yep, go ahead.
Cool. So yeah, I think everybody probably understands the necessity to collect endpoint. But I think so many people focus on kind of building a castle around their network, right? Which works for the most part, but then once somebody gets through, they basically have free reign to move around, right? So a lot of adversaries, a lot of commodity malware, is basically using simple techniques, living off the land, things that Roberto talked about, right? And not only can you just not build a castle around a network, at this point, pretty much everybody has a laptop. They're accessing data in various ways. Leaving the network, when they leave the network, they get hit like by evil maid or connected to some unsecure Wi-Fi, right? Then, they have a foothold on that computer, and then from there, your $1 billion and all the different network security products are essentially worthless, right? Yeah, you could catch them on the outbound, but, good luck if they're using Facebook or Twitter or Instagram or some other legitimate site as a C2. But so going into WEF, I think I heard Dave Kennedy talk about, WEF and Windows logs a little bit this morning, but, kind of thinking of, there's ways to collect endpoint logs other than WEF. The problem is, there's a few problems, is most of them require third-party software. So just talking to Roberto last night and heard that, somebody was installing a piece of software on all 400,000 computers, right? So how not only are increasing the attack surface, whatever vulnerabilities are in that piece of software, you now have to update those 400 pieces of software. You have to open up firewall rules from everywhere, for those logs to get from your endpoint host back to, whatever your collection mechanism is. So with WEF, right, it uses your built-in credentials, right, using Kerberos. So that prevents things like man in the middle. You're not having to install like domain admin or some local administrative privileges on every single one of your boxes, right? Because adversaries will leverage your EDR solution to pivot or move around your network if they can. The other thing about WEF is you can, with bandwidth issues, right, collecting from ATMs or something has a 1 megabyte upload link, is that you can throttle it in all sorts of different ways. You can rate limit it. You can basically filter down to like, I only want this event if it equals that, right? Like, so you could just collect one event from one host, right? And with group policy, you can set, things based on what site it's at, what subnet it has, all sorts of different variables. Like, for DNS debug logs, we only run it if there's a registry key that it is a DNS server, right? So, and these are things that like Windows themselves use. Matt Swan, I know they use WEF for ETW, right? 300,000 servers, So this isn't something that should impact your network, right? And that's 300,000 servers in production for, Fortune 500 companies that use their product, those servers for email. Cost is free, right? You're basically just paying for hard drive storage. Jessica Payne basically did a live demo on how to set up WEF, and jumping back up to the top, like the most important things about logs, like if you want anything done in security, you're going to have to get buy-in from the other company or other departments in your company. Security doesn't necessarily make any money, right? Like you save a company from losing money, but some companies like really don't have any intellectual property. They just need uptime. So if you want things done, you have to get buy-in, right? Like we went to a place over in Europe, deployed WEF in 20, 30 minutes, whatever, and just started helping out the help desk people with printer issues, right? So make yourself valuable. So this is basically an overview of the commands and the GPOs that it takes to deploy WEF. Like I said, 15 to 20 minutes. I'm not going to go through each one, but the blog for Jessica Payne's talk at Microsoft Ignite is down at the bottom. So back to Roberto.
Yeah. So now that we saw the collection into like why you need to prioritize and how to collect it, in a more affordable way. Now we talk about the transformation piece here. And one of the big issues that we're trying to solve, and it's something that we're going to be sharing soon now in probably future blog posts and things like that, is actually how to come up with a global schema into all the different logs that you have. I've had a couple conversations with different people using different technologies, and I actually asked two pieces of log, two event logs to like 6 different companies, and they parse it in a different way. So when you even like move to one comment to another one, for example, you will see different things being defined a different way, things like that. And And once again, once you start relying on the automatic transformation of the data, is when you start actually getting issues where you start naming things that are not the same in different event logs. For example, just a quick one, 4624 and 4648, right? 4624 is just authentication logs, for those who don't know, but that one has two different usernames. And the first username is actually the one that reports the 4624 log, and the other new account being used for the authentication is the account that is performing the action to authenticate to the box. Okay? So in that log, we can call the user performing the action the username. But when it goes to a different log, like 4648, which is for explicit credentials, you still have two usernames. But the first one is the one that actually is performing the action, and is actually, let's say, impersonating a different user or starting a new process with a different user. Some people call the first one, the one performing the action, the source username, and they're calling the second one the username. So when you have two logs, the definition of username are different, right? But those two values are in the same field. So when you as an analyst, you go and try to look for a username, you start getting information that it's not what you need in the middle of an investigation, right? So that's exactly what is going on, and hopefully today you can actually see a couple of examples. And global schema is actually what we're going to try to push also today.
So this is basically my life, right? So who in here parses logs? Yeah. How do you feel after you parse logs all day? Yeah, pretty much, right? Feel sad, maybe dirty and worthless, those sort of things. So, yeah. So gonna get into why we have to parse logs. So I'm gonna talk a little bit about different issues that Roberto mentioned in terms of different variations, field names, those sort of things. I'm not going to spend hopefully a lot of time on this so we can actually get into the solution to make some people smile instead of dealing with this stuff. So yeah, logs are absolutely the worst. There's just endless variations of all sorts of different things. And not only that, right, so there's possible ways to break your parsers. I don't know exactly if these work, right, but if you want to break SEP, just throw in some pipes, JSON, throw in some curly braces, XML, just throw in some greater than equal signs, right, as an adversary. Just add it in the command line, add it in the scheduled task. A lot of people will just drop logs that are parsed incorrectly, which is, the wrong thing to do from A, if your parser is wrong, right, and B, just from a malicious standpoint. Somebody is just breaking your parsers, and then, the logs go nowhere. You also have the challenge of, okay, now, how do I differentiate between a, say, Bro log and a Windows log and a DNS Windows log and Palo Alto firewall log and a Cisco ASA firewall log? Well, now I have to open up a port for each, right? And then, puts a burden back on network admins, and, now your security people are trying to, get help from other departments, and you just ask them from something else again, and you give them nothing, right? So the other thing is just values. So which one is it? Is it allow or is it permit? Who knows, right? Tipping point, SMB is not a protocol last time I checked. I think that's just TCP, UDP, ICMP, and some VPN things, and there's a few others, right? SSL TLS naming, is it a space, is it a dot, who knows, right? But why should you not be able to go from a Bro SSL log to a Suricata or some other device's SSL log? Casing, and then again, network devices are some of the worst. There's a VLAN down in the bottom, right? 1999 is a VLAN, so just don't throw an interface right into your logs. PowerShell, this is a fun one. This is in HELK, parser I wrote. So let's see here. This is everything I'm showing you right now is not parsed by WinLog beats or NXLog or some other thing that you're going to collect using endpoint logs. So you have this needs parsed, these need parsed, and everything else needs parsed. Awesome. 4104, another monster, right? Can be up to 32,000 bytes or characters. You gotta grab this. Everything below that is part of the script block text, and then you got stuff down here, and there's usually even more, file name and a few other things. Scheduled task, again, not parsed anywhere. What we put it in HELK, right?
It's coming like
Yeah, okay. Tonight, tomorrow, whatever. But yeah, this all needs parsed. Great, you create a scheduled task. Okay, now you have a name, but what is the actual command being ran? This is some of it, and there's more. So.
Okay, something actually that's in HELK already. Sorry.
Oh, it is. Yeah. So okay, so PowerShell stuff and scheduled task stuff is in HELK now. So me and Roberto work in our spare time, right? This week. Another one, NetFlow bytes. Like who here has considered using like a firewall as NetFlow? Anybody? Yeah. Well, you guys are doing it right. So why not? Like Palo Alto has it. It has network application layer detection. It's actually pretty good NetFlow usage, right? So, and again, why can't you sum all these together? Field names, is it a URL or a URI? Who knows? And then IPs are just the absolute worst. I'm not even going to get into usernames and host names because there'll be 6 slides, right? So, some of these are from Pro, some of these are from Suricata, but I'll just show you one more with Windows. So. I've found over 18 different IP address fields that are named, right, just in Windows logs. And, not only is it just 18 different fields, but you see it's a mix of IPv6. Sometimes it will have, it's a file share, so it's double slash in the beginning. Who knows what that second one is under the set update server? I have no idea. So, have fun with that stuff, but, we'll be in HELK here soon. So. More challenges, IDS alerts are always backwards. Desk port, your server is probably not listening on 1024, but that's what the desk port looks like. Proxies, and then Microsoft names a field ProDesk, submitted a TechNet. They haven't heard anything back, but that will be renamed in HELK. So what now? Got all these issues. Thanks, Nate. I'm already sad enough as it is working in InfoSec, and the job is challenging enough. So, let's talk about some prereqs. So your database should only be limited by your creativity, right? So shouldn't be limited based on field length, storage capacity, EPS, log formatting, market focus. Database needs to be flexible, right? You need to be able to solve any problem that somebody throws at you in terms of, different formats, Ceph, JSON, XML. I mean, even being able to just ingest like an HTTP web request from some little server or some little device. It has to have the ability to be open source. There's tons of smart people out there, smarter than me, that are solving problems. You can just take the stuff that they've already done, and just put it right in your product. So, and then one of the most important things is the data table, right? So it's just essentially, what does the vendor call the original name, and then what do you call it, right? So you're giving an analyst access to a database, and you have 800 fields, and they have no idea what they're looking at, right? It's just a simple Excel spreadsheet, right? Like, column 1 is your field name, column 2 is what the vendor called it, right? And you might have, if it's an integer or float or a short or whatever it is, right? Just a cheat sheet, So solution, so talking about all those problems, reason we've used HELK inside of HELK is it meets all those prerequisites and more. So sure, a lot of people in here have heard of Elastic, HELK, and those sort of things, but for those who haven't, Elasticsearch is just the back-end database, right? Storing your logs. Logstash is doing all the boring stuff, like the transformation, the normalization, quote-unquote enrichment, right? And Kibana is the web interface just to view those logs from the back end. And one of the other reasons that we chose Logstash is it has the ability, or HELK, is it has the ability, Logstash has the ability to drop into basically raw Ruby code, right? So if there's not a problem that you can solve in their 40, 50 plugins that they have, just get on Stack Overflow and, how to do something in Ruby, right? That's how we all program anyways. And then, they have XPack, they have license support, so, if it's Elastic is open source, it's not supported, that's, not true, so. This is essentially just a small overview, Logstash transforming, Elasticsearch is then storing those documents, and Kibana is visualizing it, querying it. So Yeah, so how do you solve all these problems without slowing down your pipeline? Just remember that like in assembly, in computer code, like a compare statement is literally a few bytes and it adds like no overhead to CPU. Like CPU should be able to perform millions of those things a second or more, who knows. You have a log queue like Kafka or Redis, some other database in front that you're taking the pressure of something like Logstash or your Elasticsearch or any database you have, taking the pressure of like having to ingest those events at the same time, transforming all of them, and then caching. Some of the slowest things is GeoIP lookups and AS lookups. So caching will help that. If you don't believe me, this is basically just a picture of one of my environments, about 10,000 EPS. This is without a message queue in front. But you can see in the bottom left, maybe not, but the event latency is under 4 milliseconds, and that's with over 4,000 lines of Logstash code. So, I'm going to give you a few examples on, how to not make it slow, I guess. Put it simply, we do it on time. So, perform the least expensive. So, if anybody's written IDS signatures, right, like for Suricata or Snort, before you perform like some crazy regex, you want to say like for an HTTP, say like is HTTP and request method git or something else, right? And then perform that. So it kind of works the same way in Logstash. So Cisco ASA, 30,000 log messages or something, right? So just don't like blindly fire regexes at all of them. So I do like a really small pre-parsing. And this stuff will all be in HELK eventually. Some of the networking stuff right now is just mostly endpoint. But doing like a basic Cisco ASA parsing in the beginning, so I can just literally do a compare for all these different ones before I jump into firing 100 different regexes at Cisco ASA logs. Another example is, if you're going to do geo enrichment, BGP AS name or just GeoCity location, the fancy stuff for graphs or for visualizations, is don't just again throw loopback IPs to do a lookup for geo or RC1918. This will eventually get faster once I just make it Ruby code to do starts with, but it's just a regex that's saying like starts with 10 dot. Like that's all 10.0/8, right? So, and then do a compare at the end before you do those expensive lookups. So disparate data sets. So these, Windows has IPs, Bro has IPs, Suricata has IPs, right? So assuming that you've named those fields one name, right? You then can start creating IP pairs to solve that IDS problem where things are backwards, or you just want to go from a Windows connection to a Bro connection. So fingerprinting both of these kind of creates a hash when you concatenate them, and then who knows what I was doing here, but it works. Yeah, I ran into all sorts of issues before I could actually get this done, but so this basically creates a swaps it. Yeah, so it basically swaps it. No, this is definitely mine, but okay. So it basically swaps it. So if the IP was source or if the IP was des, but just between those two pairs. And again, this code will be in HELK once we start getting network stuff. And then another thing, so we have about like 7 or 8 different IP fields that aren't source IP, dest IP, source NAT, dest NAT, those sort of things. Cisco ASA sometimes can have 5 different IP fields in one log, right? So how do you solve that problem, being able to search all IP addresses across all logs? Well, it's one line in the Elasticsearch mapping, right? So I'm going to show basically what you can do with that afterwards. So right here, we have a Windows log, have an IP address. Click this, it's a URL template, right? And I'm in basically Discover tab, just the raw logs right now, boring stuff. So you click that, that's a URL. Basically take you to just an overview. You can see at the top, basically I have a field, meta any IP, right? And that's going to search the source IP, dest IP, source NAT, log IP, a few other NAP fields, and then Cisco VPN session IP, and a few other things, right? Wasn't really able to get any dashboards, but you know, you can start with this. You know, we're able to see like processes spawned on that IP, all the DNS requests that IP has done. You get bro logs, all the HTTP requests that thing has made, right? Just do a small overview dashboard, so when somebody's analyzing, they can get a very quick picture of what that host is doing. So another one we've done is any user, right? So whether it's a desk user, source user, who knows what else eventually when we finish it all. So click it and takes you to an overview, what that user has done, all the PowerShell they've created, processes they've created, 4624 events, things that they've logged into. And then back to Roberto.
So one of the things that I wanted to show you just before we start getting to that is that, you know, you see all this stuff, like all this parsing going on, things like that. Now the idea is not just to push, let's say, you know, use Logstash or, you know, try to be a ninja in Logstash and you learn all this stuff. The idea is to, you know, go back to your organization or just whatever you're using and start kind of thinking about those things. Is that how can I put every single IP field that I have, no matter what, is called into one, and I can start doing, you know, these type of aggregations and, you know, kind of a normalization of the data. And I think that that's, you know, powerful. I haven't seen too many companies actually giving this power to their analysts, and I think that this is so powerful. I mean, like, I used to be a SOC analyst as well, and it was hard to go through every single possibility of my username, computer, IP, and things like that. So that's the idea, just in case, right? And then you can go back to the slides and probably show a little bit of like what the mapping looks like for Elasticsearch and what we can actually transform into whatever technology you're using.
Yeah, I mean, so, I mean, HELK was basically built, I mean, yeah, I worked as a SOC analyst, still do analysis work, same with Roberto, so it's, you know, it's a database sim, whatever, for analysts, by analysts, right?
Yep.
So
one thing that actually I remember when the organization that I worked before, no, actually before the bank too, there was actually a little bit of the idea of like getting, you know, hashes and things like that, and the moment everybody just enable everything, then you have one field called hashes, and you have all the single hashes that you can get from system, for example. So that's, you know, when you want to do some stacking techniques and trying to get like what is a, you know, most unique hash and things like that, you won't be able to do it just because the hash has everything in one field. Basic plugging. I think we actually talked about it yesterday. You know, we made kind of like double checking like how easy this would be. But I haven't seen actually anybody use sharing this, you know, combination of fields, which is so easy. Basically takes the hashes, splits it by the comma first. So we have a hash, let's say 75, comma, SHA-256, comma, things like that. So we split it by the comma first, and then our values are going to be split now by a equal sign, because we have MD5 equals its value. That's it. And at the end, you will have, you know, something similar. Once again, like in your own technology, I expect as an analyst to have the capability to look into every single hash that way. But one thing is that it comes down to like again what we talked at the beginning, where it's about transforming the data, but at the same time not just allowing automatic things happen and apply a little bit of your expertise. One thing that we were actually looking into is creating a dashboard that says, show me all the hashes, you know, unique hashes for a computer and also for a process name. Does anybody see what the problem here is? If I have the hashes with unique codes and unique processes? Anybody? No? All right. Pretty much we're saying that we have 4 processes, right? 4 different processes with the same hash. That doesn't make sense, right? And the thing was that pretty much when you start working with Windows Event 7 and 10 with Sysmon, the hash on Windows Event 1 is actually in relation to the process, to the image that executed, the image that was created. And with Event ID 7 is basically the image loaded. A process loading an image, so the hash pretty much applies in Windows 7 to the image loaded, and in image 1 to the process itself. That's what here makes sense. I do have kernel32.dll, same hash, right? But I have a different process. And this right here is only Event ID 7. So I'm just going to throw that out there because I've seen people building, you know, dashboards, and they don't understand exactly what is going on. So you might have some no false positive, but you will have a lot of like people don't understanding exactly what they're looking at, and they might probably freak out if they see one process. one hash with 4 or 5 different processes, right? So you might think that someone is impersonating a process, things like that. All right, so then at the end, something that it's still a work in progress, actually. It's just a help for those that haven't seen it yet. But it's just basically grabbing all these things that we talked today. And as you can see, we have Logstash, Elasticsearch, and Kibana, which is the core of all this. But something that I was, working on, and thank God I have also Nate in Twitter and Slack. We can just, change exchange ideas. But it was pretty much now take this build to the next level. I've heard a lot of machine learning, AI, all this advanced analytics stuff. It's awesome. I mean, I've seen a lot of companies do it the right way. But if you don't know how to, everybody shows you this part, but they don't show you what you have to do in order to get there, right? So this build kind of like, that was the reason why I started doing this, kind of like a free build, was to start understanding what I need to do first in order to start getting into the cool stuff. So just real quick, ES Hadoop is basically just a library. It's a package that allows you to communicate through Elasticsearch with Hadoop jobs. But the Hadoop jobs actually can be done standalone by other technologies such as Spark. So I don't need Hadoop actually servers in there in order to be communicating with my Elasticsearch. So Spark is basically, in plain words, allows you to do parallel computing, so you can execute things at the same time in parallel, and then pretty much distribute your resources, clusters all these, I would say, operations that you're doing on your Elasticsearch. So you can pull data from Elasticsearch and then start using libraries such as machine learning and things like that from Spark. And then at the end, you can actually use something called graph frames, which depends on data frames. And for those that are not familiar with data frames, it's just think about an Excel sheet, columns and rows. It's a tabular format, how you represent the data. The graph frames takes 2 data frames. I'm going to show you in a little bit. We still have 5 minutes. I'm going to show you how you can put 2 data frames and pretty much start doing graph queries. Similar concepts such as Neo4j. And I don't need a Neo4j database here. Right? And then Jupyter Lab is something that just got actually released to be used by anybody now, more robust actually than last year. It's also in this build, and it's already actually in GitHub. And this is that part that we talked today, which is a transformation of the data. So the HELK uses actually a Kafka before Logstash, and that's just for scalability purposes. And it's basically a publish, subscribe technology. So basically, all your data goes to Kafka, and then Logstash, subscribe to specific, they call them topics, to pull the data and then throw into Elasticsearch. And as you can see here, and probably you can look into the slides later a little bit in detail, but Logstash works with input filters, right, and then with output filters. Right? And then here's where you can start transforming your data with different filters per data source that you have. I do have an enrichment also from OTX, which is a threat intelligence platform. And the only reason why I now have that is because now I can actually start looking into my hashes, for example, and also the IP addresses. If you don't have that normalization of your data, you won't be able to apply all this intelligence to one field. You'll be able to start, hitting every single field. It's going to turn into a mess. And then output, of course, we divided. Actually, Nate's idea was to divide it in different indices, different indices. But at the same time, to keep a naming convention that if I just say logs hyphen star, I will hit all my indices at 1. I've seen a lot of organizations naming their indices, let's say technology 1, case 2, different names that you won't be able to actually put them together just in one query. So that was something that we were trying also to address with Logstash and show you how you can start creating your own indices also.
So that also helps on Elasticsearch backend in 6.x or the version 6. Separating things in different indices actually allows like greater storage, greater compression, those sort of things. So that stuff's huge, but it's just a small thing.
And global schema, actually those are the other ones because I don't want to say that we are right. There is other schemas that are actually being used by, for example, Splunk actually common information model. It has their own schema to name the field names in a certain way and things like that. I particularly might disagree with a couple of things, but it makes sense from a data perspective, the way how they do it, but there are certain things that I would like to do it differently. That's what I like to have a dynamic, technology that I can just, change my parts and things like that. I started my own, right, just to share with, with anybody. It's actually called OSEM. It's the Open Source Security Events Metadata. And it's just kind of sharing a little bit how I name my fields and things like that. And once again, I'm not 100% right, we're not right, but at least it's going to allow you to start thinking a little bit that there is some documentation that needs to happen every single time you create a field or want to parse a field in your database. And at the end, I already showed you this, but something that I wanted to show you before really is HELK is still in development, so I'm actually going to be releasing it probably in May, like the version that is going to have a lot of different examples. But one thing that people ask me is, how can you use graphs? Like everybody wants to do Neo4j and things like that. Awesome, good stuff, but I like to do it, I would say, in a more affordable way. And graph frames free, right? The way how it works is you have two data frames. One of them is going to show you the relationship, source to destination, right? Who is actually related to who. And the other one is pretty much your vertices, which is going to be your nodes. So pretty much here I can have Roberto, Nate, and other people, and the attribute is going to be probably my age, city where I was born, things like that. And at the end, the idea is to start applying these into our data. For example, like Sysmo logs, right? Sysmo has a parent process and it has a child process, right? So with that relationship, I can easily say, why don't you show me process that is spawn a process and the same process is spawn another process. My nodes are my processes, right? Process. That's my, it's called also my vertex. And my edge, or my edges, is pretty much the relationship from node to node, spawn, right? Simple stuff. So then I just want to do an example real quick. I say, let me open PowerShell, start command.exe, and then command.exe is start PowerShell.exe. So that would look like something like that, right? That's familiar with a lot of stuff that you do. For example, even when you start Empire or even like commodity malware, you're going to see these kind of like relationships happening all the time. And one thing that this is actually allowing me to do is that if I go to my Elasticsearch or any other technology, if they don't have a graph capability, you will have to do a lot of like OR statements. Kind of say, hey, show me command.exe or PowerShell, and then you can see here, for example, that Explorer has a parent GUI. It's a long one, but you can look at it later. But basically, goes Explorer to PowerShell, PowerShell command.exe to PowerShell, right? But at the same time, I'm going to be actually grabbing other processes that are actually executing command.exe and PowerShell. It's not efficient. So with graph frames, you can actually use kind of like a similar concept, right, as Neo4j. It has like the cipher, I would say, concept also, where you have, without any, I would say, names like, show me command.exe or show me PowerShell. No, we're talking about here patterns. Show me anything that did from A to B and from B to C based on my relationships, and then I can easily just identify my Explorer, PowerShell, command.exe to PowerShell. Now, this was thrown against, I think it was like 500 events, and pretty much I've got 3 rows, right? So I can just probably go into the other ones and see what's going on. But the idea here is that I didn't call for PowerShell, I didn't specify command.exe, I didn't specify anything. All I specified was a pattern. So that's the idea of graphing, is to start finding those patterns and start putting nodes together. And I think that I would love to have this instead of a signature that says, oh, if Excel executes PowerShell and then command.exe, trigger, right? This is going to trigger every single possibility of a relationship of 3 processes, for example. Simple stuff, and just time, I think 2 minutes. But if you need anything also, I think Nate, you want to say anything else about here, but it's just that you can contact me or Nate, and the repo is over there. And it's going to be a lot of stuff that I'll be developing with the HELK soon, that I'll be showing more examples way beyond just this. But at least from a basic perspective, I think that we're accomplishing something that a lot of other tools are not doing yet for free.
Yeah, HELK repo, I mean, get on there, install, use a Docker, other few simple things based on Ubuntu, so didn't have to kill ourselves with SE Linux or something else, right? And feel free to open up issues, right? More people using it, the better it's going to get, the easier it's going to be. Yeah, I mean, we love questions, those sort of things. You know, feel free to hit us up or whatever. So, got like 10 minutes for questions if anybody has any. So,
you know, has any questions? Yes.
Are your slides going to be available?
oh yeah. So,
Do you have the
right there, it's case sensitive. So the bit.ly link at the bottom. But yeah. So and then they're identical slides, right? So just going to take you to Google Docs. If you want to use a URL shortener, if you don't trust me, go ahead.
And once again, like if you have any questions also, like after this presentation or anything like that, you know, feel free to reach out to me or Nate. I mean, like we love to, you know, collaborate and, you know, talk to anybody that has probably better ideas. I mean, you know, this is just an approach to something that I'm not seeing out there. You know, there's a lot of stuff that of course is, you know, is expensive, right? But if you can actually show a little bit of a you know, prototype of where you want to be, you might probably task also your vendors to get to where you want to be, right? So that's the idea, and that's the reason why I started working on the HELK, is to start showing other organizations that you can do it, and it's just a matter of putting the right people together and all the right ideas together to make it happen.
Yeah, and I mean, the goal of the HELK is to basically empower anybody to use a SIM, right? And, you know, however many years of experience Roberto has and I have, and some of the stuff Brian and I work on, and all sorts of other people, right? Like, and basically make it so you're not having to buy appliances and products and those sort of things, right? Like, you can then just start spending your money on training and consulting and freaking empowering your own people, right? So, yeah.
All right.
Yep.
No questions here? No, no question.
Are you doing any pre-processing before you're sending it with the next log or whatever forwarder you're using? Or are you pretty much sending everything in like JSON and then doing the processing afterwards?
Yeah, so right now, like with HELK, we haven't really gotten to like, you know, here's the GPO, you just import or whatever, right? That stuff's coming. You're talking about like filtering. No. Again, like one of the major environments I collect from, you know, storage. Like we have just a ton of storage, so no. But I've written a blog on like using NXLog, WEF, and Elastic as like canary file, right? And then you can basically I showed an example of creating that subscription just to only collect if that canary file was open, right? So like I said, that's, and that bit.ly link for my Windows log 0 to hero talk is just basically a fire hose of everything you would need for Windows, right? Sorry, but yeah, not yet, but yes, yeah, at the bottom. So, yeah. But yeah, no. Again, like I said, if you know, bandwidth and those things are an issue, you definitely should.
So, for example,
the XML is pretty easy to write.
For example, something that, you know, that I was doing, that I was testing with other people that I was working with. Let me show you a little bit of that HELK real quick. So it's just having, you know, Kafka front, where actually a lot of things can happen, even in, you know, even at Kafka. For example, here you have Kafka going to Logstash, and all the processing happens in Logstash. But you can actually have some point, which is going to show soon, is Spark talking straight to Kafka and doing real time actually automation as well. So you can have queries being sent straight to Kafka. Logstash still feeds your Elasticsearch with all the data that it needs, pre-processed, blah, blah. But then Spark allows you to kind of like get where I was showing you here. Like, I would love Kafka to show me this. You know, right away and say, Kafka, send this, Spark, talk to Kafka, do this, show me this table and put it to an index that says, you know, analyze data. And I want this to be a dashboard, for example. So we have like two pipes, one that goes everything and the other one that goes, you know, analyze data in real time instead of having a SOC analyst doing all these queries for me.
Yeah. And then another thing with like events, so we have, basically we use for the ID, or, you know, the unique ID for the document within Elasticsearch, we use, what is it, MM3R or something? Some, whatever, hashing, right? So you could, like, even if the same event got duplicated twice, right, it's only going to store one. So that's really useful for, like, WEF load balancing or whatever, because you can't really load balance WEF unless you use something like Windows, you know, Windows clustering. because of the Kerberos authentication. You might know, might not, for those who don't. That's why I'm saying it. So, you know, sometimes 4 or 5 of the same events will get put into your database if you don't have that, but we have that in the pipeline, you know, so you can have load balancing and those sort of things. So there's a lot you can do, and eventually we'll probably start hashing Windows event logs minus, you know, the timestamp, the PID, and a few other things that are literally always going to change, right? And then you can just stack count. Like, I've seen this freaking event 400 million times over the last 7 days, like, and then just kill it on the log stash side, right? Just drop if hash equals whatever. So, yeah, there's a lot you can do.
And that's nice considering how promoted Windows logs are.
Oh yeah, oh yeah. I mean, I think in the talk, in my Windows talk, like I showed, one of the event IDs that Microsoft even recommended, like filtering if the example is right. So I think it took it down from like 3 million to like 20, just by like filtering out the one thing, right? So, and yeah, you could do that on the WEF side or you know, log stash, pipe your data pipeline, those sort of things. But yeah, WEF is fun, but you know, hopefully you just only have to pay 80, 90 bucks for hard drives or something. So but, yeah. It's good, real good question. Yeah.
Great question.
Good.
So I guess why use WEF over like WinLog beats or something that's kind of native to the Elastic suite?
Yeah. So sorry, I forgot to mention that. I should have a freaking diagram one day. But anyways, let's say you have all your WEF devices going to one server, right? One Windows server, and then on there you do install WinLog beats or NXLog. Yeah. So I kind of forgot to mention that. So it's basically just only having to install that software on 10 devices versus 400,000 or something like that.
And really, you see that benefit on the endpoints more than anywhere else.
Yeah, exactly. Yeah. And like I said, you don't have to update software, and you know, like if it's in a Windows AD environment, it's going to get the GPO, right? If it's connected, it's authenticating, it's going to get a GPO.
For example, like
being able to push out just a GPO versus software and all this other stuff. I know some SIMs and whatnot literally put like DA domain admin creds on every single box, and you're just like, all right, what's going on? You know? So
something that actually I experienced with having WinLog beat across, let's say, all my endpoints, right? It's the amount of CPU that it takes as well. Right. So that's also something that you gotta test, right? But every time, for example, WinLog beat says, hey, it's funny, so I want to talk to Kafka, and then Kafka is not available, the CPU goes up. Because this kind of gets, freaks out and say, man, I need to talk to Kafka. And it just like starts doing all this, help, right? So it just starts trying to talk. That is going to kill your CPU as well. So also from a performance perspective, I think that it's better to use native stuff from the computer, send it to web, as you can see in there, then you can implement something like a WinLog beat or NXLog. So it's not going to affect your environment as a whole. That's the same thing for those, for example, that are in the middle of like, even like, purchasing like an EDR or anything, any endpoint on your environment. There's a lot of testing that should happen, right? So that's the same thing that when I did with WinLog beat into my environment, it just killed my CPU. So I don't know what happened in there, but that's just something that actually I experienced before. So.
Yeah. And I mean, like you asked, like it's WEF is like pretty much running in the background anyways, right? Like event logs are being written, so it's like, why not just take that and then you don't have to convince somebody to install third-party software on an ATM or something, you know what I mean? So, and I mean, like, one of the environments we went to and deployed, or that I deployed WEF in, they didn't have any server, quote unquote, right? They just had like 60. We're like, well, do you have anything with like 40 gigs free hard drive space? So we just installed WEF on the print server, call it a day. So, you can get it done on make Windows 7 box a WEF server. You literally can make anything a WEF server. Scales pretty well, right? Should easily be able to handle a few thousand, up to, they say, probably about 10,000 hosts per WEF server, right? So, yeah, it's a good question.
Next question. Do we have a minute?
1 minute.
Okay, 1 minute for a question. Anybody else?
Well, yeah.
We're gonna be in the happy hour too. Like if you think about anything else, just let me know. Just let Nate know.
Well, I might just be playing Super Smash Bros.
Yeah.
Tomorrow. So.
Yeah. just interrupt Nate. Super Mario Bros. All right, thank you guys.
Yeah, thanks.